curious. We often view the honeybee through a romantic lens, as a perfectly organized communal society where every individual operates in absolute harmony. But the history of beekeeping reveals a much more aggressive relationship. For centuries, humans have physically managed hives with a primary focus on maximizing honey yields, treating the colony less like a biological network and more like an industrial resource. We've introduced standardized boxes, harsh chemical treatments, and invasive inspections that provide short-term control, but often at the cost of the bee's internal logic. This species spent 20 million years evolving complex self-regulation systems that our management styles frequently override. This creates a recurring friction. By assuming that nature requires our constant optimization, we run the dangerous risk of disabling the very biological tools that allow these vital pollinators to sustain themselves. To see how bees manage themselves, we have to look inside the pitch-black hive. When a successful forager returns, she has to communicate the exact coordinates of a food source located miles away, all while standing on a vertical surface in the dark. She uses the sun and gravity as references. Running straight up points toward the sun. Angling 30 degrees right means flying 30 degrees right of the sun. Distance is communicated through time. The waggle duration scales directly to flight distance. But there is a surprising element of individuality in this math. Researchers discovered that a statistically sloppy or imprecise stance actually yields higher foraging success than one that describes the distance with perfect accuracy. This slight overshooting gives recruited bees a wider search radius. As they fly back toward the hive, they have a second chance to locate nectar, effectively increasing the colony's overall odds of success. This shows that individuality is a biological asset. Diversity in communication styles enhances recruitment success, proving that a colony thrives on a range of styles rather than a single rigid standard of perfection. While the social honeybee gets the spotlight, they are actually the exception. Most of the world's 20,000 bee species are solitary, operating without a colony or a queen. A solitary female builds her own nest and provisions her own brood cells entirely alone. She doesn't produce honey or store massive food reserves. Her entire life cycle is focused on the immediate survival of her offspring. Because of this, their geographic footprint is tiny. While a managed honeybee colony might forage miles from the hive, most solitary bees never travel more than a few hundred yards from their nests. This localization makes them incredibly efficient. Without the burden of feeding thousands of colony members, they spend significantly more time gathering pollen for their own brood, making them elite pollinators for native plants like blueberries and squash. These native, independent species provide a level of localized ecological support that industrially farmed colonies can rarely match. They are the quiet, primary engines of our local landscapes. This reveals the bee not as a farm animal, but as a sophisticated biosensor. Their movements tell us about landscape health, floral abundance, and the presence of environmental risks like insecticides. This understanding of their natural wisdom is the foundation of natural beekeeping. It is a holistic approach that prioritizes a respectful relationship with the bees, allowing them to live in alignment with their instinctive behaviors. In practice, this means minimal interference. It involves abandoning synthetic chemicals, reducing the frequency of inspections, and using foundationless frames so the bees can engineer their own homes exactly as they would in nature. For solitary bees, the solution is just as simple: providing space. Untreated drilled wood or bundles of hollow reeds can serve as nesting habitats, allowing these native pollinators to thrive in the immediate vicinity of our gardens. Ensuring the future of these pollinators requires a shift in our role. We don't need to be managers. We simply need to provide the environment, step back, and trust the innate genius of the organisms that have been doing this for 20 million years.